Okay, guys, so today is the start of a new unit. We're going to talk about 3.1 functions. The big thing with this is, guys, by now you should know what you need to do in order to get the grade that you want. So make sure you're watching the videos, completing the homework on time. If you need extra help, make sure you're scheduling tutoring sessions to get that extra help. All that will help you whenever you take this unit test. So this is the start of a new quarter as well. It's a kind of a fresh start, but make sure you're on top of your stuff. Today we're going to talk about 3.1, which is functions. The objectives for today, we're going to understand properties of a function to determine if a relation can be classified as a function. And we're going to determine a reasonable domain and range of a problem based on real-world constraints. So the first thing is kind of like just to get your brain going, I want you to pause the video and think about it. So it says the desk in a study hall are arranged in rows like the horizontal ones in the picture. What is a reasonable number of rows for the study hall? What is a reasonable number of desks for the study hall? So think about a classroom, figure out, okay, what's a reasonable number of rows, reasonable number of desks? I'm going to pause the video, put a question in here, and I want you to answer it. For me, I think reasonable number of rows would be anywhere from 1 to 6 rows, something like that. It could be a little bit more, maybe than 6, but it'll be kind of close. Reasonable number of desks could be anywhere from 1 to 30 desks, I think is a good idea. So if you put any number between those two, I think those are pretty reasonable answers. The next question kind of leads into what I was going to ask. What number of rows would be impossible? Well, to me, anything above 10 rows seems kind of impossible to fit into a classroom. Number of desks, I think anything above 40 desks seems pretty difficult. Right? You still have enough space to fit that in there, so that's kind of our explanation. So with that little word problem, we're going to talk about discrete and continuous functions. So discrete means it's like a finite value. You can't have half of something as an example. So examples of real world examples would be people in a classroom. Okay, another one would be number of calculators in math class. So I put these examples in there because when we talk about discrete, it's going to be something that's like a finite value, like 1, 2, 3, 4. You can't have half a person. You can't have half a calculator. So it's going to be like I said, those natural numbers, those counting numbers. And whenever you graph it, it tends to look like this. Is what discrete is. It's going to be all over the place. Okay. You're not going to make a line with it, so it's not going to be continuous. An example of continuous would be time it takes to complete something. So continuous means you can have decimals. You can have half a time or half a second, half a pound, something like that. So I would say weight of animals. And whenever you graph this, right, you can have your points, okay, but you're going to be able to connect it with a line. That's what continuous is. So those are big differences in discrete and continuous. We don't talk about this a whole lot after this, but it is nice to know the difference between the two. Now the big thing from this lesson is right here. A relation is a set of ordered pairs, right? So we're talking about ordered pairs. We're talking about x, y pairs. A function is a relation in which each input is assigned to exactly one output. The domain of a function is a set of inputs. The range of a function is a set of outputs. By convention, inputs are x values and outputs are y values. So domain is your input, aka your x values. Range is your output. So whenever I put a number in, what am I going to get? And that's my y values. So on this one, it says list domain and range. My domain would be 1, 2, 3, 4, and 5. That's all my x values in a list. My range would be 11, 12. If something repeats, you only have to write it once. You don't have to write it all 3 times. Now, the other question is it a function? In order to be a function, you're going to say x values can't repeat. So if I look at this one, do I have any x values that are the same number? The answer is no. So this is a function. So next one, my domain, again, is my x values. In order to be a function, it's okay if the y values repeat. We're really just focused on the x values. So my domain is 2, 3, 4, 5, 6. My range is 0, 1, 2, 3, 4. Is it a function? The answer should be yes. It is a function because the x values do not repeat. Lastly, domain. And range. And it is a function because x does not repeat. So we're going to do some examples that are not functions here in a second. The big thing in this lesson, a function is one-to-one if no two elements of the domain map to the same element in the range. So what that means, another way to think about this, is no values repeat. So what I mean by that is x and y do not repeat. If they doesn't matter if it's the x or the y repeats, it's not going to be one-to-one. All right, so let's do some examples. Is a relation a function? And again, in order for it to be a function, x can't repeat. If it is a function, is it one-to-one or not one-to-one? So this one, my domain is my x values, 1, 5, 7, and 8. My range is my y values. Is it one-to-one? So first thing is it a function? Yes, it's a function because x does not repeat. Now, is it one-to-one? We're going to say yes, it's one-to-one because nothing repeats. Moving on, what I like to do in a mapping diagram like this, I like to make my coordinates, so 1 and 17, 2 and 17, 3 and 11, 4 and 10, 5 and 10. So is it a function? The answer is yes, it's a function because no x's repeat. Now, is it one-to-one? The answer is not one-to-one because y values repeat. So it's possible to be a function and not one-to-one. This one right here, again, I always like to list out the coordinates. Notice my x value repeats, so it's not a function. Is it one-to-one? It's not one-to-one. If it's not a function, it's automatically not one-to-one. Lastly, the big thing I want to talk about this one, if they give you a graph, another way that we like to think about functions is a vertical line test. So if I draw a bunch of vertical lines on this, they should only hit my graph, the line that I graphed, at one point. So notice it hits it here, here, here. So each vertical line only hits that line one time. So that means it's a function because your x's won't repeat. Now, if it's one-to-one, in order for it to be one-to-one, it has to be a straight line like that. It can't be a curved line. So this one is one-to-one. All right. So that's the big things from the lesson, one-to-one, functions, domain and range, stuff like that. So now we're going to tie it all together with a word problem. It says diagram shows the shipping charges as a function of the weight of several online orders. Based on the situation, what constraints, if any, are on the domain of the function? So the domain, remember, is always the mapping one, the first one. My range is my shipping charge. So constraints means like limitations. Are there any limits? So constraints on the pounds of the weight I order. The big thing is if you're going to ship something, it has to weigh at least a certain amount, right? So we're going to say it weighs more than 0 pounds. That's a big constraint. Now you could also give it a limit. You're probably not going to ship something that weighs 50,000 pounds, but you could. You're probably not going to. But the big thing is, in order to ship something, it has to weigh more than 0 pounds. Otherwise, you're not shipping anything, because if it weighs 0, that means you're not doing anything, right? So another question, it says Margaret has a monthly clothes budget of $50. She maps the amount of money she spends each month to the number of items of clothing she buys. What constraints are on the domain? So let's figure out what our domain and our range are. Domain is the number of clothes, right, that she's going to buy. Your range is your money, aka your budget. So what constraints do I have on the domain? Well, if I only have a budget of $50, my constraint is I can buy as many clothes as long as it is less than or equal to $50, right? Because I can spend up to those $50. I just can't spend over $50, so that's my budget. All right, so that's examples of real world application of domain and range. This last slide, just to review. So I'm going to end it here. The big thing is you have to do 3.1 Pearson homework. If you have any questions, make sure you are setting up tutoring times to meet with Ms. Sanders or myself. That way we can clear up any questions. Make sure you're watching the videos. Make sure you're doing the homework. Again, stay on top of things. If you guys have any questions, don't hesitate to reach out.